Hi everyone, I'm Laure Cauchard. I'm a postdoc working on cognitive ecology at the Swiss Ornithological Institute with Dr. Pierre Bize, together with Dr. Doligez from the CNRS in France, and for the results I will present you today with Dr. Julien Martin from the University of Ottawa. And today we will investigate if it pays to be smart in the wild. Well, it is well known now that for us, humans, cognitive abilities influence our evolutionary success. I will only give you a few examples as the list is very long, but we learned how to control fire, and it allowed us to cook our food to avoid disease or to warm up when it's cold. We also invented agriculture and farming to grow our own food, and tools to protect ourselves from predators. Well, with food and protected from disease and predators, we started to make babies and more babies. That is success. But what about a little bird out there in the wild? Can cognitive abilities help it finding more and profitable food, or to avoid predators, or and secure a good habitat for its reproduction? We decided to explore this question in free living gray tits. Gray tits are small passerine birds that are very easy to monitor in nature. Basically, you just have to put nest boxes outside and they will come to reproduce inside. But gray tits are also well known for their innovative abilities. They are smart, they invent new behaviors that are reported in ornithological journals everywhere. So they are an ideal species to study the link between a particular cognitive ability, the innovation ability, and reproductive success. We followed breeding gray tits, and when chicks were 5 days old, we recorded their food provisioning behavior during 1 hour and a half. The day after, we came back to test them on a problem-solving test designed to measure innovation ability. So during 1 hour on 2 consecutive days, we blocked the entrance of the nest and parents could enter by pulling a string placed below the door. But here is the trick. They need not only to pull the string but also to coordinate their movement to not release the string before putting their head under the door to be able to enter. This is challenging for a little gray tit. And finally, we continued to visit the nest boxes to measure chicks' growth and count the number of fledglings. So what did we find? We first found that birds who solved the task, solvers, delivered food at a higher rate than non-solvers, both in males, here in green, and females in purple. When we looked at the praise, we found that solvers brought more larvae to the nest than non-solvers, again in both sexes. So solvers are in black here. Larvae are the most profitable prey for chicks to grow, so solvers come more often and with more delicious food than non-solvers. We then use path analysis to test how problem solving, provisioning performance, and reproductive success are linked using our data. We compared for heat checks whether problem solving performance and reproductive success are indirectly linked through provisioning performance, or whether problem solving performance is directly influencing reproductive success. For our models to be more realistic, we also added the link of the provisioning behavior of partners because they are not independent, and linked with the timing of the season. We ran this path analysis for 2 different measures of provisioning and for 3 different measures of reproductive success. So what did we find here again? First, as expected, male and female provisioning performances were correlated, and the timing of the season influenced both the reproductive success and provisioning behavior, but only in females for the latter one. We also found again the link between male and female problem-solving ability and provisioning performance that we showed earlier, so the same results as before. But at the top of that, our results saw that provisioning performance was in turn related to reproductive success, but only in males. So the flashing arrow illustrates that we found this relationship for most of our models, but not in all. So male problem-solving performance seems to influence reproductive success through the ability to find food for the chicks. We didn't find this relationship in females, in any of the models, but we might have recorded provisioning behavior too early in the season. We were in Sweden, it was still cold in the morning and females stayed in the nest to warm up the chicks that were just 5 days old. Dads don't do this. Finally, our data did not support any of the model testing for the direct hypothesis. So does it pay to be a solver in the wild? It seems. Solvers deliver more nutritious prey and at a higher rate than non-solvers. and this seemed to influence their reproductive success. Why solvers are better at provisioning food? Maybe they are better in securing a good habitat, or they are just better in searching for food. So many mechanisms to explore here. Thank you very much for watching my virtual poster, and take care.